Hello to all friends. Continuing with the series of educational videos for the HiTek Studio software, which is related to the HiTek Brands platform, today we want to get familiar with the graphic shapes available in this software. Like pipelines, like elbows, like pumps, like this very tank you see here, valves and charts. Even how to draw charts, how to configure these graphic shapes, and how to import them into the project. Let's continue with the video and do this together. As we mentioned, today we want to get familiar with the graphic shapes. Here, as you can see in the image, I have a water tank, and I want to control the water inside this tank using two pumps, pump 1 and pump 2. I have a chart for the water level. Inside the tank, I have a display. Here, I've named one as input and the other as display. To see how full the tank is right now, I've set it up to show the percentage from 0 to 100. For pump 1, I've added a start-stop button. I've also added a pump status indicator so I know whether pump 1 is running or off. There's a valve knob for releasing water from the tank. I've added an open valve and a closed valve to control this output valve, and for pump 2, I've also included a start and stop button, a pump status indicator, and a warning as well. We'll look at the settings for this warning together in a bit to see when it's supposed to activate. So now, for example, I want to add a water tank to my project. Where should I do this from? If I want to add a water tank to the project, I can click here on Static Picture. Alright, a window will open up for me. In the Import from Library section, inside the Graphic Library, I go to the Tank section. I open the tank folder. Here, different types of tanks are displayed for me. In my project here, I use tank 201. You select tank 201. You click select and exit, and a window will open for you. Now, since I had already added this before, there's a name conflict. I click OK. You see that a window opens for you. Now here, you can set whether this tank should always be displayed for me or only under certain conditions. Here, I selected Always Display so that it's always shown. And here, you can adjust the width and length of the tank you selected, as well as its position. So, to bring in a tank, you can click on Static Picture. Go to Import from Library, and from the Graphic Libraries, the built-in libraries of the HiTek Studio software, bring in the one you want. Alright. Now, to add a pump, again use Static Picture. Again, Import from Library. Again, Graphic Library. This time, we won't go into the tank folder. We go into the pump folder, and you'll see that different types of pumps are displayed here for you. You can select whichever pump you want. Click Select and Exit, and it will be displayed on your software screen. So, we've learned that if we want to add a tank or a pump, we can use Static Picture. When we select Static Picture, a window will open for us. From Import from Library, we go to Graphic Library, and here, in the folders we have, we select the tool or equipment we want, and then we select and exit the desired equipment. Now, I want to add some of these pipelines to my project. Where should I get it from? In the Components tab, look at the second to last section. Here, it asks whether the pipeline you want to select is horizontal or vertical. Right now, in this section, I want vertical. I select vertical. A window opens up for me. Here, this is related to the pixel size of the pipeline itself. You can set it to 15 pixels or however many pixels you want. And in this section, you can also set the color of the pipeline itself. Now, here I set it to gray so that the color matches the pipe. Alright, in the Fallback tab, you can make some settings. Regarding this particular blue color, or more precisely, these distinctive dashed lines that are intricately located inside the pipeline itself, allow me to carefully click on it for a moment. This specific element that I have just recently added, as you can clearly observe, is now precisely 59 pixels in its current dimension. Break time equals 0.5s/. The width of these lines here is 33 pixels. Now, look, if I increase it, you can see that the width of these is changing. This one is for pixel length, meaning the length. How many of these should I have? The less you set it, the fewer of these you'll get. In the fallback graphic, you can again choose the color or change their shape. In this section, there's another setting called Follow Direction. It asks, now, for these lines that are supposed to move, what should their direction be? Should it go from bottom to top or from top to bottom? Here, I want the path of my water to go from top to bottom and pour into the tank, so I set it to bottom to top, meaning from bottom to top. Now, you can also adjust the speed at which these lines move. In the Follow Speed setting, you can set the speed you want them to have. For example, here I set it to 7. Alright, now you can set a condition for these dashed lines so that their movement is triggered by something being activated. For example, I set the start address for pump 1 to LB0, and for these lines as well, the movement of the lines, which represent the water inside the pipe. I also set a condition for activating these, meaning for making them move. My condition is that if my LB0, which is the start command for pump 1, is activated, then these lines should start moving. So, we can set a condition for these to determine whether they should be activated and move when that condition is met, or if they should always be moving. Okay. Alright, for the horizontal pipeline, you can do the same thing again in the Component tab under the Pipeline section. Now, here, instead of vertical, select horizontal. That means it's horizontal, and the settings are the same for horizontal as well. It has the same vertical settings, except here, instead of the follow direction being from top to bottom or bottom to top, it's from left to right or right to left. Now, look, if I change the path from left to right to right to left, you can see that the direction of movement changes, and I'll switch it back to its original state, which was left to right. You can see that the direction of movement goes from left to right. I've also set a condition for their movement. Again, I set the same initial condition that was related to the pipe of the vertical layers. That is LB0, which is related to the start of my pump 1. If my LB0 turns on, this pipeline starts moving and the rest have the same settings as the vertical pipe layers. The pixel and the length of these dashed lines. I'll confirm it. It's the same for pump 2. For pump 2, I also selected a pump from the static picture again. I placed it here. My pipeline is the same again, vertically and from bottom to top. Here, instead of going from left to right, I set it to go from right to left, so it moves from this side to the left. However, the condition for this part to activate is that LB1, which is related to the start button for pump 2, must be activated. And 4. The vertical pipeline for pump 2 is the same as well. You can see that I set its condition to LB1 turning on. LB1 is the start button for pump 2. So, I've put a start/stop button for each of the pumps. I set the address to LB0, so if it turns on, my pump 1 will be activated. For stopping it, I also set it so that if my LB0 turns off, my pump will shut down. For its status, I put an indicator light and set the condition so that if LB0 is off, it shows red in the graphic. This is its status 0, and if my LB0 is on, meaning my pump is running, it turns green in the graphic. So that I know my pump 1 is currently active. Alright, for pump 2, I did the same thing and added a start button. This time, I set its address to LB1. When my LB1 turns on, my pump 2 will start. If my LB1 turns off, my pump 2 will shut down. For its status, again I used the same indicator light, but this time instead of LB0, I set it to LB1 because the address for my pump 2 was LB1. If it's off, its graphic will be red again. If it turns on, meaning it's active, its graphic will turn green. Alright, up to this point we've learned how to add the pipelines. We've also learned how to add our pumps. We had already learned how to add the start and stop push buttons, and we added our tank. Now, I want us to be able to see the amount of water inside my reservoir, or the tank. Here, we need to use the bar meters from the Components tab. Bar charts. So, if I select the bar chart, it'll look something like this. Take a look here. Now, this gets separated from here. It gets separated from my tank. I click on this. This is the same bar graph that I selected from the Components tab. If you select the bar graph, a page like this will open up for you. It asks whether the shape of this bar graph you selected should be a bar graph or a fan shape. Well, I say no. I want it to stay as a bar graph. From below, you can choose whether it should be on the left side or the right side, or whether it should go from bottom to top or from top to bottom. Well, I'll just keep it as bottom to. You see, if you change this, you'll notice. Downward means it goes from top to bottom. Upward means from bottom to top. Leftward means from right to left. Rightward means from left to right. I'll set it to upward. That means I want it to start increasing from the bottom and go upwards. All right. I'll set its type to standard. I'm saying it starts from the very bottom. It starts from 0. You can set an upper and lower limit for this. I've considered my tank level to be from 0 to 100%. So, for the maximum limit, I'll set the value to 100, and for the minimum, we'll choose 0. Now, what value is this tank supposed to display for me? Alright, from which address is it supposed to read? Here, for my tank, I've selected the LW1 address. I'm saying, whatever value my LW1 has, that's what my tank level will be. So, if my LW1 is 20, the tank level should be at 20. Because here, we're working internally, meaning we're selecting from the registers inside the HMI itself, and we don't have any PLC or any other device networked with it. So, we have to choose an address. That is, we need to assign an address so we can control the value of this tank, the water tank, with it. So we can increase or decrease it and observe it tangibly. Alright, here I've set the address as LW1. So, whenever you select a bar graph, you also need to assign it an address, so that as the value at that address increases or decreases, the bar graph will also go up or down accordingly. Alright, that covers the address page in its upper and lower settings. The upper and lower limits. You can also choose a color. It asks you what color you want your bar color to be. Here, since I want to show water inside a tank, I set it to blue. You can also set an upper and lower limit for this tank or for this bar graph. I've now set the lower limit for the alarm. If it drops below 5, give a low-level warning. If it goes above my upper limit, which is 80, give me an upper alarm. I've also chosen colors for them. If it goes above my upper limit, it turns red and blinks, and if it goes below my lower limit, it turns blue and blinks as well. So you can also set upper and lower limits for your bar graphs. Now, in the Scale and Mark section, if you want to display the percentage next to your bar graph, you just select the Display Percentage option. Look if you want the percentage to be shown inside it. You need to check the Display Percentage box. If you wanted to show a scale next to it, either as a percentage or as the value you set, you select Display Scale. Right now, I don't need this scale, and I also don't need the percentage inside the bar graph itself. So, I'm unchecking both of them. And that's it for the bar graph settings. So, why did I remove the percentage? Because here, I've added an invisible display myself and set its address. LW1. That means whatever value my bar graph is set to, my LW1 will display that same value for me. Alright. But I'll confirm this as well. So, I've set the LW1 address to display the amount of water in the tank as a percentage. Okay, I'll hit OK. But I also wanted to draw a chart for me. Based on what? Based on the water inside the tank. The water level in the tank over time. That is, I want to see the amount of water in the tank on a chart. At different times, but where do we get the chart from? Again, we go to the Components tab to the Zero section and select Trend Zero. A window will open for us. First, you need to select a bit to stop the chart. That is, if that bit is activated, the chart will no longer be drawn and will stop. So here, we specify a bit. In the Channel section, you need to select a channel. Let me open the same chart that I added myself. I'll explain it on that. For example, right now I've set LB10 for pausing. That means if my LB10 is activated, my chart will no longer plot the water level in the tank over time. So I've set LB10. That's why I defined a channel for it, specifically for the chart, to determine which channel it should read from. I've set it to read from channel L1. I've also set its address. It's the same LW1, the same value that's supposed to be displayed in my tank. Meaning, it should get how full my tank is right now, because we had set the address LW1 for this purpose. So, using the LW1 address means my channel 1 is being used, and its type is 16-bit and signed. If we want to add other channels as well, we click on this. We click on New and select the other channels for ourselves as well. In the Scale section, you can also make adjustments. For example, you can set what color it should be, and so on. For example, you can set how many main scale division numbers there should be, meaning how many we have down here. Now, see, if I set this to 3, you can see it changed. If I set it to 4, it changes. I set it to 2. No more than 2. And their spacing, look, if you see, you can see their length is changing. The less I set it, the shorter it gets. And if I increase it too, you can adjust the length of these lines we've drawn here. It also has some personal settings, like its font, its size, or for the y-axis section. For this part, now if I increase or decrease its division number, you can see here the number changes. I set it to 4, meaning it divides 0 to 100 into 4 sections. You can also change the length of these main lines for the 4 main sections. See, the more we increase it, the longer these lines get. The number. How many minor sections should be between each main section? Right now, I set it to 2. If I set it to 3, it means from 0 to 25 will be divided into 3 equal parts. I'll just leave it at 2, and you can also change the length of the minor lines, that is, between these 2 main ones, here in the subscale length. Alright, now it says use. Use from which channel? I'll say channel 1. For the rest, again, you can set a minimum value and a maximum value. I want it to be from 0 to 100. Again, I'll set the minimum to 0 and the maximum to 100. Alright, so now we've also learned how to select the charts. We also learned about the component tab in Curve and Turn Curve and its settings. Alright, but now these patterns. Where do the patterns come from? Where should we enter the patterns, or as they're commonly called, elbows? You can also add the elbow from the Component tab in the Pipeline section. You see, it brought up an elbow for me. You can also click on Static Picture again. A window will open up again, just like before. Again, go to Import from Library in the Graphic Library, and this time, select the elbows. Yes, when you select the elbows, you'll see all kinds of elbows displayed here. You can select any shape you want. After that, a page like this will be created for you. It opens up, and it's related to the display settings, whether it should always be shown or only under the conditions you set. Here, we've set it to always be displayed, and in the General tab, you can adjust its position, placement, width, and height yourself. So now we've learned how to import tile sets into our project as well. But here, I have a valve. For the valve, you also use a static picture. Again, it's the same, import from library, graphics library, and this time we use the valves. You can see that different types of valves are displayed here, and you can choose whichever valve you want. So up to this point, we've learned how to do this. We've learned how to import graphic shapes into our project in HiTek Studio and configure them. But now, let's talk about the settings we need to adjust within the software itself for this project. Now, I want pump 1 to start when I press the Start Push button, so that water is transferred from pump 1's path into the tank, and when I press the Stop button, pump 1 should stop. Also, for pump 2, when I press the Start button, pump 2 should start, and when I press the Stop button, pump 2 should stop. I should also be able to see the status of the pumps here, open the valve whenever I want, and close the valve whenever I want. And according to the settings I want to apply, if the water level inside the tank goes above 80%, both pump 1 and pump 2 should turn off, and if it goes above 70%. If the water level goes above 70%, I should get a warning. So now, here, I've added a warning picture. I've set it up for that. I set it to indicator light mode so that if my LW1, which is the water level inside my tank, goes above 70, it gives me a warning. Make this picture blink. Make the picture blink. My LW1 is greater than or equal to 70. I specified its value here. I said, if it's greater than or equal to 70, display this picture as blinking for me, so I know that a warning has occurred and the water level in my tank is rising. Alright, so we've placed the warning here as well. Its address is this. LW1 reads the value from address W1, and if it goes above 70, it gives you a warning. But right now, since I don't have any sensor to read the water level inside the tank and see it on the HMI, I have to manually make some adjustments so that the water level in my tank goes up and down, and I can observe it. Because right now, our HMI isn't connected to any equipment, and we've used the registers inside the HMI itself. We've used the software itself. So, what should I do if I want to see this in a sort of simulated way? That the water inside the tank is increasing and decreasing. In the timer section, I've added a few conditions. For the first condition, just click Add and these pages will be added for you. So, I set a condition and said if my LB0, that is, my start switch, is in trigger condition, I put it in the condition section and set a condition. I said if my LB0 turns on, meaning my start switch receives the command. If you go into the timer function, there's a bit setting. There's also a word setting. I set it to word setting mode. Click Add. Here, there's a time option. Every 3 seconds, add 3 to my LW1 address. I had set the address for my bar graph. It's LW1, of course. So LW1 is the address for our bar graph. Every 3 seconds, if. Here, if my LB0 turns on, if it becomes 1, add 3 to my LW1 address. So this is for pump 1. The address for my pump 2 was LB0. By turning on pump 1, the water level inside the tank should also increase. Since pump 2 has also come into the circuit and the water pressure has increased, I'll set the same condition for pump 2 as well. That is, if my LB1 turns on, add every 3 seconds. 3 to the value at the LW1 address. So, every 3 seconds, add 3 to the value of LW1. Alright. So, for LB0, which is the start of pump 1, and LB1, which is the start of pump 2, we set a condition that when these are activated, every 3 seconds, 3 will be added to the LW1 address. So, what about decreasing it? When is LW1 supposed to decrease? When the valve is opened, right? If our valve opens, then the water level in our tank should naturally decrease. So, when does it decrease? If my LB5, which is the address for opening the valve, is activated, every 3 seconds. Now, I've set the value to 5, so 5 units will be subtracted from my LW1. So, for adding, the water amount is supposed to increase by 2 with each pump that comes online. 5 units are supposed to be subtracted from its value when the valve opens. When the outlet valve opens, naturally, the amount of water in the tank should decrease. So, I set it so that every 3 seconds, 5 units are subtracted from the W value. But the next condition I set, we had a condition that if the amount of water in the tank goes above 80, both pump 1 and pump 2 should turn off. This time, I set the condition on the word itself. If the value at address LW1 goes above 80, what should you do? This time, set the bit setting to set off LB0, meaning turn off my LB0. That means pump 1 is turned off. I set it the same way for pump 2 as well. If LW1 becomes greater than 80, in the timer function, I set it to set off LB1, meaning pump 2 is also turned off. Alright. For the pump close valve as well, I set it so that if my LB6 turns on, meaning the close valve is activated. This 60, the close valve, was activated. Set off LB5, which is related to the open valve address. So up to this point, we've completed all the settings we needed to do on this page. We learned how to bring this tank into the software and add it. We learned how to add it in the software environment, how to add the pipelines, how to add these LBs, how to configure them, all of that. Now, we'll load this program into our software, upload it to the device, and test the program together on the device.
Okay, we've uploaded the program into the device. You can see that the program we wrote has been uploaded to the device. Here are the start buttons for pump 1 and the start buttons for pump 2. Now, if I press the start button for pump 1, the water should move upward and fill my tank. As you can see, that's happening and my tank is filling up. I'm starting the second pump now. If needed, I'll start pump 2. You can see that pump 2 also starts filling the tank, and my graph is drawn based on the percentage of the pump's flow, the percentage of water in my tank. Here, I can see the percentage of water inside the tank. If I press this open valve, you'll see that my valve opens, and water starts to flow out of my tank. If I press the close button for the valve, my valve closes and the water flow stops. Now, as the water level went above 70, my warning light turned on, and as soon as it passed 80, the amount of water in the tank exceeded 80. You can see that both pump 1 and pump 2 switched to off mode and stopped. Because in my settings, I had configured it so that if the water level in my tank goes above 80%, both pump 1 and pump 2 should be turned off. Now I open the valve again. The water starts flowing into my tank again. And if I want, I can start pump 1 again, and also pump 2. You can see that the graph here is plotted based on the percentage of water in my tank. Now I'm starting pump 1 again. You can see that pump 2 is filling up my tank. My outlet valve is open. I'll close it. Again, if the tank level goes above 70, you'll see it gives a warning alert, and if it goes above 80, it turns off both pumps. Right now, pump 2 is on. Once it passes 80, pump 2 will turn off.